comes to trig equations in general, the big idea here is here you just need to factorize. Now, in terms of you factorizing an expression like this, you need to know the following. Like you see where there's cos here, right? We can almost think of that as like x. Let me just write it out like this so that we can easily communicate how you would want to factorize something like this. So if you had an expression like this, right, wherever you see x there, that's where the cos is. Wherever you see y there, that's where the sign is. So I am just going to show you how you would want to factorize an expression like this, so that we can just do the same for this expression out over there. So the first thing is, when you see an expression like this, right, factorizing an expression like this, the first thing that you do is you take the one at the end here and you multiply it with the other one here. You say, as long as it's in this format, this times this, you multiply it and you find out what you get. You're getting here 3x squared y squared. Now, what you want to do with this 3x squared and the y squared, you want to get factors of 3. You want to get factors of 3 that can give you a 4. Okay. You see, factors of 3 that can give you a 4, it's basically going to be 3 and 1. Yeah. You see. Yeah. Now, what you then want to do is, from a 3 and a 1, to get a 4, you would need to say a positive 3 plus a 1. Do you see? Yes. Yeah, you see. So 4yx, you would get that from saying 3yx plus 1yx. Do you see? Okay. Yeah. So now that you've done these two things here, all you need to now do is you can easily go back to your main expression and then rewrite this 4yx as 3yx plus 1yx, like this. You see here where you see the x squared there, it's just going to be x squared over there. Well, why is this thing not writing? Okay, it's writing now. So here you're going to have x squared, right? 4yx here, this is going to give you 3yx and then just a yx. And then at the end of the day, we still just have 3yx, you see, plus 3yx. I mean 3y squared equal to 0, you see. So let me actually move this a bit to the middle so that my mini arrows can show what happened. So from this 3, what you may call 3yx here, right, we were able to determine factors that can give us the number in the middle here. So that now you can factorize by grouping. You see, here you can take out a common factor, and then here you can also take out a common factor. And if you look nicely here, the common factor is just x. Yeah. And then here you have 3y. Here you can do the same. The common factor here is a y, right? Yeah. Yeah, so this is like y. And then this is like 3y. This is equal to 0. And then if you can look nicely here, you see the x plus 3y, and here also x plus 3y. This, do you see it's a common factor here? Like if you look nicely, can you see it? Yeah, I can. Yeah, so you can take that out as a common factor, and then what you're going to be left with is just this x here plus this y over there equal to 0. Do you see? Yeah. Yeah. So this is something you can do for yourself, even on your answer sheet, to like help you remember what you can do to factorize this. Because now you can even do this on like the side of your answer sheet, so that you can see for yourself, okay, fine, wherever I see x, let me just put a cos theta over there. And then wherever you see y, you can just put a sine theta over there, you see. And then you'll now see, okay, fine, when this thing is factorized, this is what you're actually going to be dealing with, equal to 0, you see. And then your next step, you can say, therefore, the first bracket equal to 0 is going to give you your first solution. And then the second bracket equal to 0 is going to give you your second solution. You see, there you go. And then from there, you can just work on each of them individually. Like from here, solving for theta. This can go over to the other side. You're going to have 3 sine theta equal to negative cos theta. And then here you want to be strategic, you see. It's easier for you if you divide both sides by a cos, so that you can end up with like a tan, you see. So divide here by cos theta, or let's say divide by negative cos theta. And then, or we can just do it by cos theta. We don't have to do the negative whole thing. We can just divide by cos theta. And then we would end up with -1 here, and then here it's like 3 tan theta. Do you see?
Yeah.
Yeah. So that's the idea. So from here now, do you see that you'll be able to like just carry on?
Then you can carry on with
No, I mean like we'll be able to carry on from here.
Yeah, I can.
Yeah, because from here we know that we'll be able to just say tan theta is equal to -1/3. Now, when you get a reference angle, right, we need to make sure that we use the value without the negative. You see, always use the absolute value of this to work out a reference angle, and it just refers to this as a value without considering the sign. So your reference angle is equal to shift 10.
You don't consider the sign?
No.
Okay.
You don't, because you're getting a reference angle. You're getting something you can refer to help you get the answer. So from your reference angle here, the answer we're getting here is, let's see, shift 10 1/3. You're gonna get the 18.43.
Yeah.
It's like 18.43. Let me just write it down. 18.43. Now that you have a reference angle, you can now look at your sign, and your sign, you use it to see which quadrants you should work in, you see. So you have this and that. What do I see here? Let me see here, this and that, right? So it's like C, A, S, T. 10 is negative in the following quadrants. 10 is negative over here. 10 is negative over there, you see. So you know you need to work in the quadrant 180 minus your reference angle, and you need to work in the quadrant 360 minus your reference angle. So let's see here, 360 minus your reference angle, you see. And then now, obviously, we will be able to like carry on from here, because here the next thing is, if you take your value for theta, you now know it's going to be equal to 180 minus your reference angle, and then plus K360, K is the element of integers. And then from here, your answer, let's...
Oh,
pardon?
Never mind. It's okay. I got it. Never mind. It's fine.
Okay, cool. So let's see here. This is going to give you 161.57, or theta is equal to 180. No, we say 360 plus. Also, we have to put the plus K360 here. Plus K360. But what did they ask you? They asked us to get solve for theta. Well, yeah, if you're gonna just solve for theta, I mean, you don't necessarily have to put the plus K360, whatever. But then just because if you put it, you don't get penalized for it if it's not needed, you can just always put it, you know. Then one day leave it and you forget that you had to put it there.
Can I ask
Yeah.
Isn't it, you said like 180 minus 18,43 plus K360? Isn't it for 10?
Oh, 180. Yeah. Yo, I'm totally forgetting we're working with 10. K 180. Yeah, definitely. You're right. Thank you for the heads up. Yeah. Yes, it's definitely 180. And then here we have the 360 minus the reference angle, and then plus K 180. K is the element of integers. This is gonna give us let's see here, wait, what is the answer here? The answer here is like 341.
Yeah.
0.57, and then plus K 180. K is the element of integers. You see?
Yeah.
Perfect. So that's going to be for this question here. You see, the one thing that I can maybe safely say stands out in this question that we have done is this way of factorizing, because this way of factorizing, it's like it's proper, you know, like if you can just get your head around this, then you will not be stopped when you see stuff like this, because the idea would be to look out for the trend, you know, there's something squared on the far left, something squared on the far right, and then something in the middle. That's usually your indicator that you should factorize using this method, because this is like the generic way. This is more like the orthodox and basic way of factorizing that was like taught, I think, grade 10 or something. So it's easy to have forgotten it.
Yeah, for sure, for sure.
Yeah. So let me just stop this one here, and then we can. So on the so amongst the